Good day, learners. I'm Sir Francis from Lipa City Science Integrated National High School, Division of Lipa City, Batangas. And I'm here to discuss to you the Physical Science Grade 11 module. Our first topic is all about the general types of intermolecular forces. And after going through this video, you are expected to, first, describe the types of intermolecular forces present in substances, and 2. Identify the types of intermolecular forces present between among substances. What is happening when a liquid boils? Why different molecules or liquids boils at different temperature? In order to answer these following questions, we need to learn about the intermolecular forces. Intermolecular forces are electrostatic interactions between molecules. Atoms within molecules makes covalent or ionic bonds with each other. Also, molecules participate interaction with polar molecules. Let's look at different types of intermolecular forces. First, we have ion-ion interaction. Large ion solid are held together by this network of ionic bonds, which is stronger intermolecular forces because it includes formal charges. Next is ion-dipole interaction. But first, let us first understand what a dipole is. The covalent bond of water molecules is polar. Oxygen is more electronegative than hydrogen, and it will pull the electron in the bonds toward itself. Because the bend shape of the molecules, when we combine these vectors, we can see that water has overall dipole, or a side of molecules with some electron are excess and other side are electron deficiency. Dipoles can make electrostatic interactions because the partially negative side is attracted to positive charge, while the partially positive is attracted to negative charges. When sodium chloride dissolves in water, the sodium ion makes ion-dipole interaction with the negative side of water's dipole, and the chloride ion makes ion-dipole interaction with the positive side of water's dipole. Each ion can make several pieces of interaction which store a lot of energy, which is why sodium chloride will disassociate with water in the same place. Next is we have dipole-dipole interaction. This is when dipole interact with each other just like pure water. While in liquid form, water molecules will move such a way so as it will form electrostatic interaction between the negative end of one dipole to positive end of another dipole. In this case, this dipole-dipole interaction qualifies for the special types of bond, which is the hydrogen bond. This is when dipole generated by HF, NH, and OH. These are the example of the formation of the hydrogen bond. This is one of the strong dipole-dipole interaction. This is especially strong because the nitrogen, oxygen, and fluorine are most electronegative elements. So they will create most strongly polarized bond, resulting with very strong dipole. And if we have strong dipole, we can have very strong dipole-dipole interactions.
What are hydrogen bonds? An attractive force called a hydrogen bond can exist between certain molecules. These bonds are weaker than ionic or covalent bonds because it takes less energy to break these types of bonds. However, a large number of these bonds going on can exert a strong force. Hydrogen bonds are the result of an unequal charge distribution on a molecule. These molecules are said to be polar. If we look at a water molecule, we can see the oxygen atom shares electrons with two different hydrogen atoms. So, in total, this molecule has 10 protons, 8 from oxygen and 1 each from the hydrogen atoms, and a total of 10 electrons, 2 shared between the oxygen atom and hydrogen atom number 1, and 2 shared between the oxygen atom and hydrogen atom number 2, and the other 6 non-shared electrons from the oxygen atom. So this water molecule is electrically neutral, but it has a partial positive side, the hydrogen side, and a partial negative side, the oxygen side of the molecule. The electrons are not shared equally within the molecule, as they have a higher probability of being found closer to the nucleus of the oxygen atom, giving that end a slightly negative charge. So the hydrogen atom's end of the molecule will have a slightly positive charge. These charged ends weakly attach the positive end of one water molecule to the negative end of an adjacent water molecule. When water is in liquid form, there are a few hydrogen bonds. Solid form, many hydrogen bonds, and when water is steam or gas, there are no bonds because the molecules are too far apart to form any bonds. Hydrogen bonds only form between hydrogen atoms that are covalently bonded to an oxygen, nitrogen, or fluorine atom.
Next is the van der Waals forces and the London dispersion. These forces, they exist in all molecules, but they are predominant forces in all nonpolar molecules. So let me describe these forces using this kind of illustration. Let's say we have two atoms with a positive charge at the center, and we know that electron cloud, the atoms are surrounded by a negative charges. The nucleus in the center has a positive charge because of the proton. So when the electrons are evenly distributed in an atom, we can have a nonpolar atom. Now, because the electrons are constantly moving, there's gonna be a moment where one side of an atom will have more electrons than the other side. In that case, the electron cloud is now distorted, so we have an excess negative on the left and deficient of negative charge on the right side of the atom. So basically, we can say that this particular illustration will look like this. So there's a net negative charge on the left, and because the right side is electron deficient, it is more positively charged. Now this atom is now called polarized, and it is now called a dipole. This dipole doesn't last long, so it may last for a very short period of time, or it may be called as a temporary dipole. So what happens if we take this dipole and place it next to a nonpolar atom where electron cloud is evenly distributed? So the electron with full of force will accelerate them towards the positive side of the atom. And so this electron cloud becomes more distorted, and this atom becomes polarized. And so what happened is now we have two polarized atoms. Now you need to be familiar with the term called polarizability, and it basically describes as the probability of an atom's electron cloud being distorted due to the random motion of electrons. So let's have an example. Let's compare fluorine and iodine. Fluorine has 9 electrons and iodine has 53 electrons. So because iodine has a lot more electron than fluorine, it is more polarizable. It can create a temporary dipole, will more likely to form in an iodine atom than a fluorine atom. Now notice that the positive side of this will attracted to the negative side of the other. So this will feel a force of attraction that accelerate them, and so these forces that attracts these atoms together, they're known collectively as the van der Waals forces, also known as the LDF or the London dispersion forces. Now for this example, it was a temporary dipole. A dipole is basically a polarized object or polarized molecule where one side is negative and the other side is the positive. And the reason why it's a temporary dipole is because it can go back to its original state. The electrons on the left side can diffuse towards the right side because this negative charge is attracted to the positive charge. So it can be turned into its nonpolar state where the electron cloud is no longer distorted or the electrons are distributed evenly. So keep that in your mind that this temporary dipole doesn't really last long, and it depends upon the size of the atom. The larger the atom, the larger the London dispersion force is. Now, the dipole on the right is an induced dipole. And the reason why it is called an induced dipole, it is because it was induced or created by the first dipole when this dipole became when electron cloud of the dipole become distorted. And it is caused by an electric lock for this atom to become distorted, thus creating an induced dipole. So make sure that you understand the word induced dipole. It is just a dipole that was created by something else and it doesn't last long and it can be back into a non-polar state. So these forces that hold or attract this dipole induce dipole molecules together, and those are the van der Waals forces or the London dispersion forces. They are the weak and they are also found in every molecule. However, in nonpolar molecules, they are dominant forces. So these van der Waals forces explain why some nonpolar molecules have higher boiling point than any other nonpolar molecules. Let's consider these halogens for example. We have fluorine, chlorine, bromine, and iodine. Fluorine is a gas, chlorine is also a gas, bromine is a red liquid, and iodine is basically a purple solid at room temperature. Of course, the boiling point of fluorine is, let's write here, negative 188 degrees Celsius. The chlorine is negative 34 degrees Celsius. Bromine is 59 degrees Celsius. And iodine is even higher for about 114 degrees Celsius. Now, if we write down the molecular weight of this atom, we can have this. The molar mass of fluorine is 38 with 9 electrons. The chlorine is 70.9 with 17 electrons. Bromine is 159.8 and it has 35 electrons. And the iodine has 253.8 as the molar mass with 53 electrons. So as we travel down in the periodic table, in group 7A, that is the group where all the halogens are, notice that the number of electrons increases, and so the molecules are becoming more polarizable due to the increased number of electrons. So the molecular weight and the number of electrons are proportional. So as the molecular weight increases, the number of electrons also increases. Now with these molecules with high numbers of electrons or higher molecular weight, those molecules will have more London dispersion forces. And so you could see the trend of the boiling point increases also. Iodine has a highest boiling point because it has more, high molar mass and more number of electrons. So molecules with number of electrons or higher molar mass values, they tend to have more van der Waals forces, and thus they will have higher boiling point. So you make sure you understand this relationship. So boiling point is directly related to the amount of the London dispersion that a molecule has. So here's a question for you. Consider the molecules of methane, ethane, propane, and butane. So which of the following four molecules will have the highest boiling point? So looking at the chemical formula, there's CH4 for ethane, C2H6 for methane, C3H8 for propane, and C4H10 for butane. So if we analyze the molar mass of each molecules, the molar mass of carbon is 12 and the hydrogen is 1. So for the methane, we have the molar mass of 16, ethane has 30, propane has 3 times 12, it's 36 plus 8, it's 44 molar mass. And for butane, we have 4 times 12 plus 10 is 58 as the molar mass of the butane. So the molecules with the highest molar mass will tend to have the highest boiling point, so it's gonna be the butane. Methane has the lowest boiling point because it has the lowest molar mass. All of these molecules are non-polar, so anytime you have hydrocarbons that contains carbon and hydrogen bonds, it is a non-polar molecule. So remember that the intermolecular forces enable molecules to stick or attract to each other. That is why there are also called intermolecular forces of attraction. They are different from intermolecular forces, which are attractions among atoms within a molecule. And then we have three major intermolecular forces: the dipole-dipole forces, hydrogen bonding, and the London dispersion force. The dipole-dipole force occurs in polar molecules. Remember that when we say dipole-dipole, there is what we call the partially positive and partially negative ends of each dipole. Recall that a polar molecule creates a permanent dipole moment as a result of having a highly electronegative atom bonded with a less electronegative atom. And hydrogen bonding, remember that if a hydrogen is bonded to oxygen, nitrogen, and fluorine, because hydrogen is the least electronegative atom, and when it bonds in highly electronegative atom, it will form hydrogen bond. And remember, only oxygen, nitrogen, and fluorine bonded to hydrogen create a hydrogen bonding. And lastly, the London dispersion force. The electrons of an atom in a molecule are constantly moving. However, there are many times when electrons move to one end to another, making such end partially negative while the other end becomes partially positive. This uneven distribution of electron results in temporary dipole in a molecule. The temporary dipole induces is instantaneous dipoles on neighboring molecules. Again, these are the general types of intermolecular forces.
Question: hydrogen bonding occurs when hydrogen is bonded to N, O, or F. Which of the following has hydrogen bonding? Option 1, H2S. Option 2, NH3. Option 3, NO2. Option 4, CBr4. Intermolecular forces for CO2. Option 1, dipole-dipole. Option 2, dispersion force. Option 3, hydrogen bonding. Does HF have hydrogen bonding? Option 1, no. Option 2, yes. What explains the very high melting and boiling point of water? Option 1, strong dipole-dipole bonds between water molecules. Option 2, dispersion forces which are present in all molecules. Option 3, asymmetrical shape of the polar bonds. Option 4, strong hydrogen bonds between water molecules. Which is the second strongest intermolecular force, after hydrogen bonding? Option 1, London forces. Option 2, dipole-dipole attraction.